Math 1314, Tyler Junior College, Section 3.5, Rational Functions, Graph with a Slant Asymptote. By far, this is the series I've done to date with the most number of videos. And reflecting over all the videos that I've done so far, finding the domain, the difference between polynomial and rational functions, using arrow notation, identifying vertical asymptotes versus holes, vertical asymptote examples, identifying horizontal asymptote examples, graphing via transformations, graphing using the 7-step technique, another example of graphing using the 7-step technique, slant asymptotes, and this video makes me wonder if I needed to say all the things I needed to say. And the answer is maybe not, but my goal in making these videos is not really just to say, here's college algebra. Granted, it helps with college algebra. My goal in these videos is to show you some things that you can think outside of the box, perspectives. Why do things work? How do things work? How do we make conjectures? How do we test conjectures? And in some cases, how do we prove something is true, such as when we derive the quadratic formula, or when we derive the vertex of the parabola. So if you've been watching these videos and going, man, this man talks too much, it's not just because I like making a lot of videos, because as much as you're working watching these, I am working making them and uploading them and to my classes, putting them into Canvas. I'm doing this in hopes that somebody who thinks they can't do math goes, yeah, I can, and somebody who can do math and likes it realize it's more than just here's a bunch of steps to follow. So hopefully somebody benefits from me. If that somebody is you, put a comment, let me know. All right, final video. We're going to graph the function that we used in the previous video, f of x equals x squared minus 3x minus 4 over x minus 1, and we're going to graph it. Now, if you didn't watch the previous video about slant asymptotes, I would recommend going to watch it. It's a relatively short one. And if you're wondering where this came from, we did a synthetic division on this to get a quotient of x minus 2 plus a remainder of negative 6, which was on top of the divisor, x minus 1. We're going to graph this using the same strategy, the 7-step strategy, which now I guess we could say 8-step strategy, because now the question is there a slant asymptote? Normally in the 7-step strategy, though, that's included with locating a horizontal asymptote. If there's not a horizontal asymptote, see if there's a slant asymptote. But I'm going to buzz through the 7 steps a little quicker. Ooh, that marker's much juicier. Glad I changed. Are there any symmetries? In the word, no symmetries. You can test them, but I can tell just by glancing at it that this will not have y-axis symmetry and this will not have x-axis symmetry. It will have a symmetry. You'll see it in a little bit. Step 2. I'm going to reverse the, no, I'm not. I'll do that if I film this series again. For the y-intercept, we simply have to substitute 0. Substituting 0 will not give us a problem because it doesn't make the denominator equal to 0. If we put 0 on the top, we get negative 4. If we put 0 on the bottom, we get negative 1. And negative 4 over negative 1 is 4. So we will have a y-intercept at 0, 4. The x-intercepts, we have to solve the function equal to 0. But as I mentioned a couple of videos ago, I believe, to solve a fraction equal to 0, you simply have to solve the top equal to 0. So we have to solve x squared minus 3x minus 4 is equal to 0. This will factor into x minus 4 and x plus 1. That means we have an x-intercept at x equals 4 and x equals negative 1. So one x-intercept is 4, 0, and the other one is negative 1, 0. Sorry for the pause. I'm making a conscious effort to stop saying at the beginning of many sentences, so. Our x-intercepts are 4, 0, and negative 1, 0. For the vertical asymptotes, we would start by looking at the denominator. You know what? I forgot to see if this will factor and cancel. It won't. But it's to your benefit to see if a function will factor and cancel. take that back. This never had a chance. Because if this would have factored and canceled, that means that this would have divided evenly without a remainder. So based on the previous work, this had no chance of factoring and canceling. Still, you should always ask yourself, can I factor and cancel? Because that will preempt the discussion about vertical asymptotes and holes. I digress. This will not factor and cancel, so the original function is the reduced function, and the only number that makes the denominator equal to 0 is x equal 1. It can't make the reduced function equal, 1 makes the function undefined. The function is its own reduced function, so 1 also makes the reduced function undefined, so it is a vertical asymptote. There is no horizontal asymptote. We can tell that immediately because the degree of the numerator is greater than the degree of the denominator. But as was discussed in the previous video, if the degree of the numerator is exactly 1 more than the degree of the denominator, 2 is 1 more than 1, then the quotient of the division problem in the form y equals the quotient is the slant asymptote. So there's no horizontal asymptote, but the slant asymptote is y equals x minus 2. So we will graph that line by using slopes and intercepts. Speaking of graphing, let's graph everything we have, because our next step is to go get other points, so we need evidence where we have none. We have a y-intercept at 4, so 1, 2, 3, 4. We have two x-intercepts, 1 at 4 and 1 at -1. We have a vertical asymptote at x equals 1. We have no horizontal asymptote, but we have a slant asymptote at y equals y equals x minus 2. Just a reminder about graphing something in slope-intercept form. The y-intercept is a starting point. So to graph this slant asymptote, we need to go to -2 as a starting point. And the slope, as a ratio of rise over run, the slope is 1, so we can think of it as 1 over 1. Rise, run. That means from our y-intercept, we can rise 1 and run 1. So rise and run, do it as many times as you want, but here is that diagonal line. So that is our slant asymptote. And I believe we actually have enough evidence. I would like a little bit more evidence. I know what happens to the left of the vertical asymptote, and I know what happens to the right of it, but I would like one more dot here between 1 and 4. So for the other points discussion, let's just put in 2. And we can put it into either. I think I'll put it over there. I mean, I can put it here. Actually, let's put it here. 2 squared is 4. 3 times 2 is 6. 4 minus 6 is -2. -2 minus 4 is -6. 2 minus 1 is 1. -6 divided by 1 is -6. I was going to say we can put it in either version. This isn't reduced. This is just an equivalent form. But putting in 2 here was easy because it kills that. We get -6 over it. Wait a minute. We're getting a different answer. We should get the same answer. I must have messed something up. 2 squared is 4. I better write this out. 2 squared minus 3 times 2 minus 4 over 2 minus 1. That's 4 minus 6 minus 4 over 1. That's -6 over 1, which is -6. Oh, you big dummy. Yeah, that's what we'll get if we put 2 over here, because that disappears. 2 down here gives us 1. -6 divided by 1 is -6. Sorry, brain freeze. The point I was trying to make before I went off the rails was if you do the synthetic division or long division to locate the quotient and hence the slant asymptote, the answer to the division problem, including the remainder, is equal to the original function. So putting 2 should have given us the same answer here and there. Didn't mean for that to be that messy. All right, 2 (-6) is another point I'm going to plot. 1, 2, 3, 4, 5, 6 down, and then over 2 is here. At this point, I think we have enough evidence because we're going to approach both of these asymptotes, hit the points that we said we're going to hit. Ta-da! I've seen some messed up graphs. These are tame by comparison. I challenge you, especially if you want to get onto a graphing utility like Decimals.com, really type in some messed up numerators and denominators and see what kind of havoc you can wreak. And that's the end of this oh so long series of videos. I hope that you learned something. If you have any questions, shoot me a message or comment on the video.